Okay. So I welcome you to this session. It's me, Kauku Bernard, who's going to handle you in this session. So my names are already there. Those who haven't seen me, you can see my screen now.
Yes.
Okay, that is your teacher who is going to be teaching you in this lesson. Thank you for making it in time. Who can remind us what we looked at last time? What did we look at last time? Members, what did we look at in Geography Paper 1 last time? Raise up your hand and contribute something. Teddy, you were here last time. So we all don't remember. Looks so funny. But basically, we are looking at the theories for the origin of the Earth. We looked at different theories for the origin of the Earth. And today, we want to dive into the distribution of continents and ocean basins. Can we mention some of the continents and ocean basins that we know? Raise up your hand and you tell us examples of ocean basins and examples of continents. Yes. Raise up your hand and give us those examples.
There's Africa.
Someone mentions Africa. Yes, another one. That is a continent. Another one. Yes, Dorcas.
We have Asia, then ocean basin, we have Indian Ocean.
Joy. Joy.
Another ocean basin, we have the Pacific Ocean.
Yes, that is the Gorge. Gorge. Brilliance. Unmute and speak.
Ocean basin, we have Pacific Ocean.
It's already mentioned. Mention a different one. Don't you see on the screen?
Atlantic Ocean. Atlantic Ocean.
Okay. David Katete.
We have the Mediterranean Sea.
Can we have oceans? Tricia. Unmute and speak. Emmanuel.
Pacific Ocean.
Come again.
The Arctic Ocean.
Okay, watch again.
Continent, we have North America.
Please mute. Dorcas.
We have Europe.
Another one?
We have South America.
Good. Okay, I think that's a good start. Thank you very much. Let's someone take us through this slide. Dorcas, you're still unmuted. You can speak. Read for us the introductory slide.
Distribution of continents and ocean basins. The Earth is made up of continents and oceans. These are
Yes.
these are 7 continents and 4 oceans. The nature of the Earth is particularly the origin and the distribution of these continents and oceans is physically mysterious and therefore for a long time has been a subject of contention and controversy among geographers and geophysicists.
Okay, so here we are looking at the Earth made up of continents and oceans. 7 are continents, 4 are the large oceans you can mention. So the nature of the Earth is particularly the origin and distribution of the distribution of these continents and oceans is basically not clear. That's what we can say. It is not clear where they originated from, but scientists have put up different origins. Others oppose themselves, others come to conclusion. They try to give evidences to support their theories and the rest. But so above all, we shall look at that continental drift to know the origin of these continents and ocean basins. Okay, next slide. David.
The continents of the Earth occupy only 29% of the total Earth's surface, with 71% is occupied by water bodies. The contribution of land in both hemispheres is not uniform. Much of the land mass is found in the northern hemisphere, 39.4% of the northern hemisphere, while the land mass covers only 18.6% of the southern hemisphere.
Boj, can you see that very well? Yes? Is that clear, members? So we are looking at basically that when we talk of oceans and the continents, you find that 29% of the total Earth surface, the whole Earth, the way you can see it here, 71% is occupied by water bodies. So if we give an example, you see all this is water. Do you see why I'm highlighting? The whole of that is water. And then you find that now 39.4 is basically, I mean 29% is for land, 71% is water. But then out of the 29% that we are remaining with, you will find that much of the land mass is found in the northern hemisphere. That is 39.4%. And then 18.6% in the southern hemisphere. So when you get, if you have your Earth, you know it is spherical, and then you divide it into 2. You will find that in the northern hemisphere, we have much land. That's why even when we are considering the largest continents, you consider Asia as one of the largest continents, and it is in the northern hemisphere. Also talk of the North America, Europe. So much of the land in the upper part is large. It covers 39.4%. And then the southern hemisphere covers only 18.6. That includes Africa as a continent, South America as a continent, Australia. That is the area. But much of the land is covered by water. You see in the comments, someone says, I now know, sir. Okay, that's cool. So that is an introductory part. Someone else will take us through the next slide. I will pick, that is who? Isaac. Let me pick Isaac, then join next. Isaac, unmute and speak. Okay, Deco, take it on.
Hence, the northern is called the land hemisphere, while the southern is a water hemisphere. The land hemisphere is composed of North America, Africa, Asia, Europe, and more than a half of South America. The remainder forms the water hemisphere with the pole near New Zealand. Land covers about 47% of the land hemisphere and 11% of water hemisphere.
Thank you very much. So after knowing that when you divide this land, when you divide the earth, you find that we said that 29% is the only land, 71% is water. Then the northern hemisphere has a larger area in regards to the percentage of land. The southern hemisphere has less percentage of the land coverage. And so we conclude and say that the northern hemisphere is the land hemisphere. Then the southern is the water hemisphere, because too much water is still in the southern hemisphere. So the land is composed of, those are the continents, and then the water hemisphere, it has those continents, and the percentage is well spread. So today we are entering deep into geography, paper 1. Okay, next slide will be for Joy. Joy.
It's important to note that almost all continents are in pairs except Antarctica. Africa is paired with Europe, North America with South America, and Asia with Australia. Also, all continents have got an antipodal relationship with Asians in a sense that whenever land occupies one part of the earth directly.
Oh, directly. Yes, there's something missing there. So we say that also all continents have got an antipodal relationship with oceans, in a sense that when land occupies one part of the earth directly, water occupies the other part. Do you get the point? So taking an example, when we consider, when you look here, this is land, water. Sorry about that. Water, land, water, like that. So you find land, water, land, water. So that is what we call the relationship, where you find, you can't find that land is next to land. That's what we are meaning there and what we are explaining. In the chat, someone is saying, yes, teacher, that's okay. Then we are saying that some countries are paired. We shall watch a video shortly to see how these continents are paired. When you look at South America and Africa, you find that there is a way they are joined. So here we are saying Africa is paired with Europe, North America with South America, something like that. So let's see in the next slide. That is a new heading. The heading says theories of the continental drift. So someone take us through the introduction. Rosia. Is it Rosia or Rosia? Yes, take it on.
Louisa.
Okay, Louisa, thank you. Are you able to
The
read?
theory. Continental. Yes, I'm reading.
Okay.
Continental drift is a hypothesis that states that continental masses have changed their relative positions as a result of fragmentation and are part of original land masses. It is now widely believed that continents moved through time and still moving even today. Several theories of continental drift have been advanced as discussed below.
Yes, we want to look at different theories that brought about the distribution of these continents. So whenever you hear the word continental drift, you know that we are basically looking at how these continents and ocean basins were distributed in the positions where they are as of now. So it is a hypothesis. It is a belief. It states that continental masses have changed their relative positions as a result of fragmentation and part of original land masses. So here we want to see different theories put forward to explain the distribution of these continents and ocean basins. So there are many theories such as the seafloor spreading, the Huygens theory. We talk of the tectonic and the rest, you know, most of these theories. So I'm going to play you a video that starts with continental drift. So be keen, watch every step, then from there we can continue. Yes, or Jack? Or Jock? Rafael? Rafael?
Yes, thank you so much for the opportunity. Yes, I can hear you. Can you hear me?
Yes, very well.
Yes, thank you so much for the opportunity. Now, I'm a teacher as well, but I wanted maybe some more light on the students. Some students may not know what the word hypothesis could mean. Thank you so much.
Okay. So when we say a hypothesis, this is a statement, sorry about that. You can call it a statement. We can call it, let me continue to explain it more. I can get another slide to put more evidence. So when we talk of a hypothesis, here basically we are looking at a proposed explanation. It is trying to bring further investigation, further explanation, or you find that you are putting reasoning. This reasoning can be aided with evidences, or at times it is without truth, but at least people will have to believe it. So a hypothesis is a proposed explanation of something that happened. Members, is that clear? A proposed explanation. Yes, a proposed explanation. So it's like someone who can say, please, could you try to explain how this happened? So you sit down, you come up with your own reasoning, you even give it examples to make sure that people will believe that this one really existed. So that is a hypothesis. Then Raphael, come again.
Yes, thank you so much once again. What if I say a hypothesis is is a statement that is not yet proven right or wrong. Am I right?
Yeah, that is also very right. So it is a statement still that is not yet proven right or wrong. Yes, that is okay. Okay, thank you very much for giving us that overview. So I'm going to play a short video or longer, but at least we need to understand the continental drift. I'm sharing my screen shortly. Tell me you can see my screen. Can you see my screen?
Yes.
The black screen.
Yes, yes.
Okay.
Yes, you can.
Let's talk about the theory of continental drift. Why don't we look at a world map? Have you ever seen one of these? Well, of course you've seen one of these. Everyone has seen a map of the world. In fact, you probably first saw a map of the world when you were in kindergarten. And what you may have noticed, similar to so many people before you, is that if you look carefully at the continents, the giant land masses covering about 29% of the Earth, if you look at them carefully, they almost look like puzzle pieces, like they fit together. Especially if you look at certain parts of the world, like the eastern coast of South America and the west coast of Africa, for example, they look like they belong together. Now, I hate to break your hearts, but this is not a groundbreaking discovery. In fact, people have known this for hundreds of years. Most people have just taken it for granted that that's just the way the continents look. But there have been a few brave scientists throughout history who have thought that it must be something more. Let me introduce you to one. This is Alfred Wegener. Alfred Wegener was a German meteorologist. He studied weather. He lived in the late 1800s and early 1900s. And as a weather person, a scientist of the atmosphere, of course, Wegener spent a lot of time looking at maps. And so he noticed this strange shape phenomenon just like you did. The problem is he couldn't get past it. He actually devoted his whole life to it. He came up with a radical theory that suggested that the continents were actually once connected and then somehow ripped apart to where they are today. He came out and he said, "I think the continents are moving." Of course, people thought this was kind of a silly thought to have. How could a continent possibly move? But Wegener really thought that.
So you heard that statement that you can call him Wegener, you can call him Wegener. So for him, he said that the continents are moving, but people couldn't believe him. And that's what we are calling a hypothesis. Let's continue.
That this was the case. And so he devoted his whole career to studying this and coming up with proof of this radical idea. In fact, Wegener didn't just think the continents were moving. He actually believed that there was a time when they were all connected, and they have since drifted apart to their current locations. He even came up with a name for that supercontinent that existed in the past. He called it Pangaea, the supercontinent that he believed existed about 250 million years ago. Pangaea, or Pangaea, is actually an appropriate.
Sorry about that. I want to correct also. You will find that in some books, this word is written as. Can you see what I've written?
Yes.
Yeah, in some books it is written as Pangaea. So the spellings may differ. So we are looking at the correct pronunciation. So in some books you will find it as Pangaea. Like that. So let's proceed.
Name. It's a Greek term that means entire Earth or all Earth. So if you think about it, when all the continents were together, if Wegener is correct, it would make sense to call that landmass Pangaea or Pangaea. Here's what he thought it looked like. You can see within this diagram the modern-day continents of North America, Africa, South America, Antarctica, India, etc. But they don't look quite the same way they do today. And of course, they're in totally different positions, all connected into this one supercontinent. Now, people thought Wegener was a little bit nutty. And so he knew that if he was going to make any headway with this idea, he had to come up with evidence. And so we're going to take a look at 4 pieces of evidence that Wegener put together to prove to the public that the continents had in fact drifted. Let's take a look at his first piece of evidence. We'll go back to this map here. Now, the first piece of evidence we've actually already discussed. It's simply the observation that the continents appear to fit together. As simple as that. Wegener didn't believe that this could be simply a coincidence. He feels like there's no possible way the continents would have this appearance just randomly. And so this becomes evidence number 1. We will call it the apparent fit of the continents. The fact that they look like they.
So the apparent fit of continents, at times it is called the jigsaw fit. You've heard about that? So Wegener's hypothesis, he's trying to give evidences in order to support his theory. Let's continue to see it.
Fit together. And just to expand on that a little bit, essentially the coastlines of the continents appear to fit together, kind of like the pieces of a puzzle. But that's not enough. So Wegener went back to the drawing board. He dug through piles of books and libraries and became quite interested in fossils and other evidence of prehistoric life. In fact, Wegener became particularly interested in that guy who just swam across the screen, the Mesosaurus. Now let me tell you about the Mesosaurus. This is an ancient reptile that lived only in shallow fresh water. What's interesting, though, is that there's only 2 places in the world where we find fossils of this freshwater creature. One place is the eastern coast of South America, and the other is the western coast of Africa. Now, there's a couple possible solutions for this. Now, either the Mesosaurus was living on one of these continents and somehow learned how to fly across the Atlantic Ocean to inhabit the other side of the other continent. But that's not likely. The Mesosaurus certainly could not fly. And we know the Mesosaurus couldn't have swam across. The distance is just too great, and they can't survive in salt water. So that's out of the question. Maybe the water was frozen and he walked across? Well, that's a possibility, but there's really no evidence to support that. And so what Wegener said is that while the Mesosaurus roamed the land, Africa and South America were connected, and they were able to freely walk across the land masses. And then after going extinct, the land masses were torn apart and separated, carrying some of the fossils to what would become South America and some to what would become Africa. Interestingly, Wegener looked into this and found that there were other organisms that lived in the past that had similar fossil distributions. Cynonathus, Lystrosaurus, and Glossoteris being amongst the more notable ones. These fossils all have these very unique distribution patterns that suggest that the continents were once together. And in fact, if you reassemble the continents and map out the locations of these fossils, they line up perfectly. So that's our evidence number 2. We call it fossil correlation. Correlation simply means matching up. So matching up fossils on either side of the ocean. To summarize, identical fossils have been found in the rocks on either side of the ocean, and therefore the continents were once connected and must have drifted apart. But Wegener knew he needed a stronger case, and so he went back to the library yet again and became fascinated by rocks and geologic structures like mountain ranges of the past. And he found a really interesting pattern, not unlike what he found with fossils. In fact, if we go back to our world map here, and let's zoom in on the North Atlantic here, if you look at the mountain ranges in the northeastern United States and the mountain ranges in northern Europe, they match up perfectly. And what I mean is that they are made of the same type of rock and the same age of rock. Now, of course, anything is possible, and the same exact rocks could have formed in two different locations at the same time. But geologically, that's unlikely. A better explanation is that these mountains were once connected, and as the continents moved, they tore them into two. And that becomes evidence number 3. We call it rock or mountain correlation. And what we see is that identical rocks and mountain structures have been found on either side of the ocean, suggesting that the continents were once connected. But we need one more, and this is probably the most complex of them all. Again, Wegener returned to the library, and this time he returned to his roots as a meteorologist, and he began to look at past climate data, meaning he looked at evidence of cold and warm weather in different parts of the world, and he found something fascinating. See, he first looked into glaciers. So glaciers are these giant rivers of ice that move slowly across the Earth's surface. And of course, glaciers have to be found in cold parts of the Earth. Today, they're restricted to only the highest mountaintops and of course the north and south poles of the Earth. Something interesting about glaciers is that they move, and when they move over the rock beneath, they leave evidence in the form of scratches that we call glacial striations, which you see here. Now, how does this relate to continental drift? Well, if we look at our map, if you look in the present-day tropical rainforests of South America and Africa, you will find glacial striations. Here, in these two regions, you find these scratches in the bedrock. Now, if you think about that, how could there be glaciers in a tropical rainforest? Unless it wasn't always a tropical rainforest. This suggests that these continents were not always in their warm equatorial regions like they are now. They were once down near the South Pole where it could have been cold enough to have glaciers, and they have since drifted apart. But Wegener wanted more from this climate data, and so he began to explore a little deeper. And that's when he came across this rock. This is a sedimentary rock called bituminous coal. We know it because we burn it for energy. It's a fossil fuel. What we know about bituminous coal, if you were to look in earth science reference tables, you would see that bituminous coal is made from compacted plant remains. So picture tropical plants like this dying on this forest floor and getting compressed over millions of years to form coal. Now let's look at where coal is found on Earth. Anywhere you see this little icon, we have found coal deposits. Now let's think about this. Coal forms from tropical plants, yet it's found in Antarctica, in northern Europe, in northern Asia, and the southern tip of Africa and Australia, and in the northern United States. These are not tropical climates, yet they have coal, which is evidence of a past tropical climate. And so this, just like the glaciers, suggests that the continents have moved over time. And that becomes evidence number 4. Paleoclimate data, or past climate data. The observation that coal has been found in cold areas, and that glacial evidence has been found in warm areas. And with these 4 pieces of evidence, Wegener published his book, The Origin of Continents and Oceans, in which he laid out his case for continental drift, suggesting that all the continents were once connected in a supercontinent called Pangaea, which existed about 250 million years ago, and since the continent has ripped apart into the present-day landmasses that we know so well. Later in his life, Wegener took an expedition to the North Pole. And in this expedition, he wanted to gather more evidence to support his theory of continental drift. Unfortunately, on a very cold, dark, stormy day, Wegener set out on an expedition to gather food for his colleagues, and he never was heard from again. Wegener died of exposure and was frozen in the ice, and his body is actually still there today, frozen forever. The sad thing about that is that Wegener was never able to explain what made the continents drive, what made them move, what made the supercontinent rip apart. And so he died before his theory would become accepted by the scientific community. He never got to see his life's work come to fruition. That's the story of continent.
Okay, we have seen Wegener trying to explain the origin of these continents and ocean basins. Hopefully it was wow for you. Those who have been having problems in explaining Wignard theory, that was a good step. And maybe we can give ourselves a chance to interact and give what we learned from that very video. Learning is open to all of us. So someone to summarize the theory and another one to summarize the evidences. Raise up your hand. Someone to summarize the theory, another one to summarize the evidences. Yes, Gracious.
I want to do the evidences.
That's cool.
So should I wait for someone to go for the other part, or?
No, you can give us that. All of us were listening.
Okay, from Alfred's theory, his evidences are 4.
Yes.
The first evidence is the appearance of the coastal lines.
That's
For
good.
example, the line of the coastal line of South America and Western Africa.
Yes.
Then similar animal fossils in
Yes.
South Africa, in South America and West Africa.
That's good.
I've forgotten the name I gave in the example.
Mhm.
Then identical rocks and mountain structures. For example, in forgotten the
Someone
mountains
can
they
help
gave.
her? Okay.
The mountains they gave, the region where the mountains are. Someone can help me with that.
Yes, we were all watching. You can raise up your hands. Yes, Tricia.
The identical rocks were found in Australia, Africa, and South America.
Okay. Continue, Gracious. The fourth evidence.
The fourth evidence is it climatic something, I think.
Okay,
Right?
past climate, something like that. Summarize it like that.
So in regions where some climatic evidences were found, like the current, like in Africa and South America, it's a warm region, but they are, how do they call them? So let me first do the other one.
Yes, fine.
In places like the cold places, we find things like coal, where in most cases, such things are supposed to be found in warm regions.
Yes. Yeah, we have got the point. Thank you very much, Gracious. Someone summarize the theory for us. Summarize the theory. You can raise up your hand and summarize the theory. Joy in the chat says that Wegener's theory states that all the continents of the earth were once together, but later drifted. That is okay. Yes, more suggestions. So Wegener says that the earth was once, and it was called Pangea, isn't it? Isn't it, members? So this Pangea was later split into 2, and the splitting formed which continents? Which continents? Yes, Borge. Isn't it that?
Yes, teacher.
So more to that, we are seeing that this landmass Pangea was surrounded by a large water mass. What was the name of that large water mass? So this large water mass was called Panthalassa, something like that. That was the large water mass that was surrounded by Pangaea. Now, to continue exploring into the theory, you find that Laurasia and Gondwanaland, in the middle, they had a sea, and this sea was called Sea of Teith. Yes, Boj, your hand is up. So, Boj, you can speak. So, we are saying that Wiggin stated that. Yes, I want people speaking. Boj, your hand is up, you're not speaking. In the chat, Boj still says it was one continent known as Pangaea. That was okay. So, it was one continent known as Pangaea. It later split into two. That is Laurasia, Gondwanaland. So Laurasia moved in the northern hemisphere. Yes, Raphael? Raphael?
Maybe to add on to, oh yeah, thank you. Maybe to add on to that, I was of the view that we needed to know when exactly the Pangaea divided into two. Now, in my view, or my suggestion would be, we would say that Wagner argues out that the Pangaea was located in the present South Pole, and it was surrounded by a large mass of water, which was called the Panthalassa. And then it was during the Precambrian period, that is about 250 million years ago, that the Pangaea started drifting northwards. Now, it was after some time, after drifting northwards, then the Laurasia broke into two land masses. That was the Gondwanaland and the Laurasia. I think the years are quite so.
Okay. Thank you very much, Raphael. I think I'm going to involve our colleagues to continue reading the theory. I'm going to display the entire section here, and then we can continue to dive into it. That's very good. I'm going to share screen. So, can you see my screen?
Yes, sir. Yes, sir.
Okay.
Yes, sir.
So I'm going to use the site that we normally see. Please subscribe. So I got courses. I want us to go directly to that section. Those who have subscribed, you will now see how to navigate here and there, so that we can get someone to continue reading, and then we capture all the years comfortably. This is geography, paper 1. Phrase this. So from the time we started these free classes, we have so far looked at the introduction to physical geography. We looked at the structure of the earth. That was last time. And at least last time I sent detailed notes, right? And today we shall have the detailed notes on the origin of continents and ocean basins. So we had this in our slides, the theories, and now we are basically looking at the third theory. May I know if you can read this very well? Who is using a computer? Alvin, are you using a computer?
Yes.
Yes. Let's use at least 10 minutes. 10 minutes. Actually, 4 minutes. Read for us very fast, and then all of us will continue to follow.
Okay, in 1915, Alfred Wegener, a German climatologist and geographist, published a book titled Origin of Continents and Original Basins, in which he argued that continents change their position over time. This led to what is now known as Wegener's theory of continental drift. According to this theory, the present-day continent continents originated from one landmass known as Pangaea. Pan means all, Gaia means Earth. This single static landmass is thought to have been positioned somewhere near the South Pole, and they were surrounded by big expanse of water or mega ocean known as Pantlassa. This landmass later split into supercontinents known as Laurasia, Atlantis, and Gondwana. The two separated by a narrow water body known as the Sea of Thetis. Sea of Thetis, okay. A shallow and meandering water body. Stages of continental drift. The first stage during the
for stage, we can
Did I proceed?
Okay, proceed.
Okay, first stage during the Carboniferous period, in which a supercontinent Pangaea was surrounded by mega ocean Pantlassas. Wegener believed that Laurasia lay across the equator, while Gondwana lay near the South Pole. Gondwana is believed to have experienced large-scale glaciation during the Carboniferous period. That is approximately 345 to 280 million years ago. Then the second stage, around 200 million years ago, flight of continents took place. Continents began to drift gradually and broke into pieces. Laurasia, Angara land, and the Gondwana land, known as the Indian part of Gondwana land. In the third stage, during the Mesozoic era, the space between Laurasia and Gondwana land got filled with Tethys Sea, and gradually got widened during the Paleozoic and early Mesozoic eras. Numerous cracks developed in land masses, leading to separation and consistent drifting. Fourth stage, around 100 million years ago, westward drift of North America and South America led to opening of Atlantic Ocean. So in the fifth stage is the ongentic stage, in which mountain building activity took place. While Himalayas and Alps were formed with folding sediments of Tethys Sea, and westward drift of North and South America led to folded edges and formation of Rockies and Ardens. Finally, during the
Cretaceous period, approximately 137. Yeah, continue.
Gondwana land gave rise to southern continents, namely Africa, South America, Antarctica, Australia, the subcontinent of India, and numerous islands in the southern hemisphere. Laurasia broke up to give rise to North America, Europe, Asia, and land masses in the northern hemisphere, such as Greenland and Iceland.
Yes, finalize.
Forces responsible for continental drift due to the cumulative effect of gravitational forces, pulsing force, and the force buoyancy. The continental drift was equatorwards. The pulsing force was due to increasing centrifugal force from the poles towards the equator, as the Earth is not perfectly round and there is a bulge at the equator. Due to tidal currents resulting from rotation of the Earth, the continental drift was westwards. Tidal currents are due to the attraction of the moon. However, later these two forces were found to be inefficient reasons for drifting of the continents, which is counted as criticism of Wegener's theory. Criticism of the continental drift. Should I continue?
Yes, let's see the criticisms, why they don't take this other scientists. Continue.
There are flaws in the jigsaw fighting. Thought it seems appropriate if 5,000 fathom isobar is considered as an outline of continents. Wegener talks about the role of forces like buoyancy, tidal currents, and gravity, but these were not strong enough to drift continents. He advocates directional movement either westward or equatorward, but movements have taken place in all directions. Alfred Wegener failed to explain the pre-Carboniferous history. He did not explain that why the drift began in the Mosaic era and not before. The theory did not take oceans into consideration. The theory did not explain formation of oceanic ridges and island arcs. The Earth's crust is believed to be too rigged to permit large-scale motions. Wegener's ideas have not offered a suitable mechanism justifying the displacement of larger masses for a long journey. Present status of the continental drift theory. The continental drift theory was not accepted. Sorry.
A moment. Thank you very much. So I'm going to share the whole of this theory on our WhatsApp group so that we continue to read more about it, and then we can ask more questions in the group. Now we have what we can read. So the theory, we have explored it in depth. I had one of the teachers was saying that we need to accompany it with the years. So the years are all here. When everything happened, his theory, he had to bring some evidences to support it. However, it was criticized. But above all, it was taken and considered as one of the theories. So to conclude this, I've said I will share the lessons. I will share the theory in our WhatsApp group. Then we continue to talk about this theory and other theories as they come. Let me share this screen to conclude the lesson about the Wegener's theory. So sorry, the time is not our friend, but I want to conclude the theory like this. Is there some sound? Were you hearing anything?
No.
Oh,
No.
Sorry about that.
No.
No.
Oh, sorry about that. Let me put sound.
We'll try to understand what Alfred Wegener's theory of continental drift means. According to Wegener, all the continents formed a single continental mass. This supercontinent was named as Pangaea, which meant all Earth. Then a mega ocean surrounded this single continental mass, and this mega ocean was called as Panthalassa, meaning all water. Alfred argued that around 200 million years ago, the supercontinent Pangaea began to split. Pangaea first broke into two large continental masses, which was named as Laurasia and Gondwana land. These two continental masses formed the northern and southern components, as one was in the north and the other was in south. After that, Laurasia and Gondwana land continued to break into various smaller continents that we see today. So this was Alfred Wegener's theory on continental drift. If you want to see more of such educational content, make sure you're subscribed. By doing so,
So that is how we can say Wegener theory is now complete. I really thank you for your active participation, those who gave in answers, whoever contributed. It was a nice lesson. I also thank the teacher who joined us. So that's how we have wrapped up our lessons. Remember to subscribe for more of these lessons. You need to pay and continue learning from home because digital learning is the new normal. So the teacher has posted the question in the chat. You can follow it up. I will also accompany it with more questions. Yes, Esther, your hand is up. Esther, speak.
I'm asking about the timetable. We're having only one geography there.
Yeah, it is one. The challenge is that, first of all, we are running free classes. We couldn't put all the subjects there. We are running free classes. Secondly, it's like we couldn't fit all the subjects there as of now because we run from P1 up to senior 6. So the time frame was limited and we never wanted subjects to collide as we conduct these free classes. So for those students who will continue to subscribe, all teachers are available, all subjects are available. So at least when you subscribe, we may even put these teachers who have been teaching to first rest a bit as we put the other subjects also on board. So the free classes are ending next week. So beyond next week, you and your parents decide on what you can do next. So thank you for listening and for your active participation. Any other question?
Master.
Yes.
Master.
Yes.
Master.
I'm hearing you. Please speak.
How much are we paying? How much are we paying?
Okay. We have been organizing these sessions to explain to your parents how much you pay, but here you can all know it. If you want to have digital learning, your mind should not run to only Zoom classes. Your mind should not run to only Zoom classes, but we provide a full package in a way that you are supposed to subscribe to the website where all these lessons are. The teachers mark, they grade all the assignments that you do. Everything is done on the website. Leave alone putting work on WhatsApp and the rest. We are using WhatsApp because you don't know how to use the other website and you are not members of that website. Everything is done well on the website when you are subscribed and you are there. For example, you saw that, let me go back to that website. Where can I find it? You saw this. Now, when you finish this topic about the origin of continents and ocean basins, at the end of it all, you find assignments. For example, there is assignment 1. Can you see my screen? Is my screen clear?
Yes. Yes, sir.
Yes. So at the end of that topic, you will find an assignment. Assignment 1 on origin of continents and ocean basins. So when you tap there, you find questions, and these are max 75. You are supposed, that is, to spend 2 hours and 15 minutes answering them. Answer any 3 questions. Question 1, explain how Wigner's theory of continental drift explains the formation of major relief landforms in East Africa. Question 2, what is meant by continental drift? Explain the relevance of Wigner's theory in evolution of continents. To what extent have tectonic movements been responsible for the development of relief and landforms in East Africa? What is meant by continental drift? Explain the factors responsible for the present distribution of continents and ocean basins. These ones are the theories. Then justify the view that the present day continents have drifted from their original position. And B, the continental drift, that is, you have to give the Alfred Wiggin. So now when you reach here, you say start assignment. When you start assignment, you can write these theories either on the computer, you can write in the books, you take pictures, and then you upload everything here. The teacher will receive it still on the same platform, go through your work, marks it, and the results are actually returned. You get results, and you find that when you go under messages, they will show you that, for example, you have scored maybe 36 out of 40 in this assignment. So everything is within the system. Reports are easily generated on the system. This has not started in lockdown. It has been there since 2015. There are students who have been learning from here only, not even going to schools, because we promote and do everything from here. So I was sharing about the prices. So to study online is 500,000. We don't have monthly payments because you will not have completed any package on the website. That's why we can't have a monthly package for online learning. You have to be graded. You have to be promoted from one level to another. But if you can study for 1 year on the website, it is okay. But we can't give you a monthly package. It may not help you because all the content is on the website. You have to sign up an account. You are given the courses of your subjects to have them for a full year. For example, you are in senior 5, you study all subjects of senior 5, not just portions. That's why we say digital learning is 500,000. So teachers have to engage you on Zoom classes. You continue reading. Now, like when we don't have classes, members are idle on the group. But if you are subscribed, you are busy reading on the website. You are busy reading because you have content for a full year with you. Something like that. So then you can download or you can buy some subjects of primary or secondary. The prices are there. Or you can read this content on the website. 1 month, 20,000, 3 months, 50,000, half a year, 70,000, a full year at 100,000. So I request you keep asking from the WhatsApp group, and then we help you. Okay? That's cool.
Okay.
Yes. More questions? For those doing literature, we can come in again and proceed.